Hello, and welcome to Calculus by Dummies for Dummies. Today we're going to be talking about limit statements and how they're used and how to evaluate them, as they approach a number c or as they approach infinity. First, let's talk about limits and what they are. Limits are used to determine what happens as you grow infinitesimally close to a number. It doesn't tell you what happens exactly at that point, but rather what happens as you get really close to it. First, let's go to Marie as she talks about limits as they approach infinity.
As limits as x approaches infinity is basically given by three rules. If we're given this function, or this example, f of x over g of x, the first rule is that if the degree of g of x is greater than the degree of f of x, the limit would equal 0. This is because, for example, if this were the case where x squared were on the bottom and x were on the top, as this number approaches a larger and larger number, this number is squared, and it would become much larger, much faster than the top one. So these two numbers right here don't even matter, and so therefore it would start to equal 0, because you'd have, if you put in 1,000 over 1,000 squared, obviously this one would be like a much larger number. So this one would equal 0, because as each number gets bigger, the bottom grows faster than the top does. And then the second rule is if the degree of g of x is less than the degree of f of x, then the limit doesn't exist. And that's basically the exact opposite, because if this, for example, if this one were to be bigger, the degree, and you put in a number such as 1,000, it'd be 1,000 cubed plus 2, which isn't very relevant, over 1,000. So this number would get a lot bigger, a lot faster than this one. So it would just keep growing and growing and growing, and it wouldn't reach a certain number. So it would be does not exist. And then the last example is that if the degrees both equal each other, the limit equals the two coefficients of the highest powers. So for this one, as this one approaches a greater number and this one approaches a greater number, they both equal each other. They're both very similar. So it would equal the coefficients over the coefficients of the largest powers, which is both x squared. So we'd have a 1/2, because this would be a 1 in front, and this is a 2 right here. So the limit would equal 1/2.
Next, let's look at how to evaluate limits as they approach a number. For this example, we're going to use the limit as x approaches 5 of the equation x squared plus x minus 12 over x squared plus 6x plus 8. First, we're going to start off by factoring the top and the bottom equations. The top will factor into x plus 4 times x minus 3, and the bottom factors into x plus 4 times x plus 2. Next, you're going to cancel out anything that you can, which in this case leaves us with x minus 3 over x plus 2. Then you're going to plug in where you're evaluating the limit at. So in this case, we're evaluating the limit at 5. So we plug that into the top and bottom, and that leaves us with 2/7. Now that you've mastered limits, here are some takeaway problems for you to try. At this point, pause the video and try these problems. Thank you for joining us today on Calculus for Dummies by Dummies. We hope you've learned how to evaluate limits as they approach both infinity and a number c, and we hope that you have a fun time in the rest of your math career.